Hello, this is Ahmed Gama. I'm Masters of Data Science student here at UDC. This is my final year, and I used to be a research assistant at CUIB. Today, I will discuss one of the most important topics in computer science, which is permutations, backtracking, and or we can also say for it the brute force approach. The brute force algorithms. Okay. To discuss the brute force algorithms, we will discuss something called permutations. Permutations in mathematics. If you want to take L permutations from n elements, if all of the number of ways, or the actual number of ways you can use to choose L elements from the whole n numbers or n elements and rearrange them, the whole number of rearrangements possible. For example, if we want to choose two numbers from the array 1, 2, 3, we want to choose two numbers and get the size 2 permutations. It could be something like this: 1, 2, 1, 3, 2, 1, 2, 3, 3, 1, 3, 2. And here, the total number is given by the, for example, if you want to choose 2 from 3, it could be 3 by 2. If you want to choose 3 from 4, it could be 4 by 3 by 2. This is the total permutations. Okay, so how to generate the above output? For example, if we are told to get the two permutations from the whole output, which is 3, how to generate this output? This is one of the most important computer science problems and mathematical problems. And because this way, if we are asked sub questions like, what are the permutations that sum up to 3, for example? It could be 1, 2, and 2, 1. What are the unique permutations? 1, 2, 1, 3, 2, 2, 2, 1, 2, 3, and so on. So to solve this, we will use two concepts in computer science. The first concept we will be using is trees, and the second concept will be backtracking. Trees are hierarchical data structures. They are a kind of directed acyclic graphs. They are directed acyclic graphs, but here each node has a number of children or a number of neighbors, and the difference between it and the directed cyclic graph is that in trees, we can't have a node that is child of both. For example, a directed acyclic graph could be something like this, but not a tree. A tree here, there is no node here or child shared by two parents. We have a root of the tree. The root is the root here is the node that has no parent, and we have leaves that have the nodes without children. The other all of these are, of course, some kind of nodes. This is the first concept of calculating the permutations, and this shows the power of directed acyclic graph and how they can be used to solve such problems. The other concept is backtracking. Backtracking is an algorithmic technique that uses recursion and depth first search. And this is a kind of graph search. Where a child is generated a leaf here, leaf generated leaves generated first, or children visited before parents. We will explain further about all of this when we take an example. But the general approach, you remove an element and you use that element to generate a child. You exploit the children of that element further till you access a leaf. Then you return the element back till you access the root and you get to the second, to the other path. So a path is exploited completely before, for example, here we in backtracking here, you go like this here and then go here and then get back here and then get back here and then go this way. Then after you return here, then you are able to go from here to here. Then you return back here. Then you go here. Then you return back. Then you go. Then you return back. Then you go above, and so on. And this is backtracking is used to generate brute in the brute is a kind of brute force algorithm, that the algorithm that generates all of the combinations of the given elements, and is used in such problem like solving Sudoku or solving, for example, the n queens problem, and so on. Now let me put the three pieces together. Suppose that we want to generate all the permutations of the elements 1, 2, 3. First of all, let me introduce two things. We have input and we have a bucket that is used to hold the currently generated permutation. For example, first we will have the input that contains the whole numbers, and we have the bucket empty, an empty bucket. This is the input, and this is the bucket. Okay, we want to generate all of the permutations of this number. So this will be the root of the backtracking tree. Okay, the general idea is we generate the children recursively, but we will not get back to a sibling unless we complete the children till the leaves. Then we can get back to the siblings. Whenever we go in further, we remove some element from here and put it in the bucket. And when we come back from a child visited here, when we come back, we remove the element from here and return it back to here. Okay, let me explain. For example, here, we could remove the first element. 1 is removed from here and put in the bucket. Here, the remaining array will be something like that. 2, 3, and the bucket will contain only 1. And as I said, we won't go to a sibling. If we go to a sibling, that could be breadth first search, DFS. No, we will go in depth first search manner. Then we will take the 2 and put it in the bucket to generate a child of this. Here, only 3 will remain, and the bucket now will contain 1 and 2. Okay, still we have something in the array. We will further put it in the bucket. Here, we will put it in the bucket. We will take this and put it back in the bucket. Here, the array will become empty, and the bucket will become 1, 2, 3. Okay, so this is a type. When we arrive here, since the input array here is empty, now the input array becomes empty and all of its elements are in the bucket. We can then yield this, or we can store this in somewhere, because this is leave. Okay, when we return back, this is the question here. We remove 3. When we return back, we put 3 back. Okay, and the bucket itself will become having just 3. Now we return back here. Is there any way that we can push another element from array? No, there is no way. So return the 3 back. Return the 3 back. Then push the 2. When you push the 2, no, return the 2 back. I mean here, we return the 2 back from this bucket into the input array. And we will try to push 3 instead. The next element, push the next element in the bucket, remove it from the input array. It will become something like that. The input array will contain only 2, and the bucket will become 1 and 3. And from here, simply remove 2, put it in the bucket, input become empty, and bucket become 1, 3, 2. And this is a leave. Store it. When you return back the 2, there is no other element to try. Return back when you return back the 2, then return back the 3. Also, here, all the elements are exploited. Now, we return back the 1 here, and we put the 2 instead. It becomes something like that. When the remaining elements are 1 and 3, and here is 2. From 2, you can get, you remove 1 to become here 3. 2, 1. Then you remove the 3, you will generate 2, 1, 3. And when you get this, you return back to this, and you return back to this, because there's no element here. When you return back to this, you try the 3. So you put 3 instead of 2. Instead of 2, you put the 1 instead of 3. You put the 3 instead of 1, because here you return 3 back. So the bucket will become 2. Here it becomes 2, 3. And then push back the 1. 2, 3, 1. And this is the leave. Store it, and so on. And if you get further because you will return back the one here. You will return back the 3 here, and you will return back the 2 here, and you will try in 3. Bucket will become only 3, 1, 2. And here you can generate either, you can put either 1, which is you put 1, remaining 2 from here. You remove this 1, put it here, 3, 1. Then from this you could generate by putting 2, which is here, emptying the input array and put it back 3, 1, 2. And from here you store it and get the 2 back, then get the 1 back and use here the 2. So 1 will be remaining here, give them 3, 2, and here this will become empty, 3, 2, 1, and so on. When you return back, no more element. When you return back, no more element to try, because we tried the 1 and 2. When you return back, also none to element. Of course, you have stored this somewhere. You will return whatever you stored here from the root. Okay, now let me solve this interesting problem in LeetCode, which is about permutations. Okay. This is the permutations. This is the question. You have this array here, and you are asked to generate the whole permutations from this array, like changing all of the possible positions of all of the possible elements. Okay. This is the class of the solution. Let me define an internal function. Let's call it backtrack, because we are using the concept of backtrack. Okay, this backtrack will have a root or a node, because this is a node. Let me call it node or whatever, or let me call it, a node. This is a bucket. I will use the bucket as a node. And I have the input array. I have, let me say it like that. I have input array. I have node or bucket, or let me say node. And I have the node here is empty by default, and I have the collector. This is the collection of the whole leaf nodes. Okay. Let me define here. I will return to this later on. Stopic criteria or the recursion here. The stopic criteria is when the input array becomes empty. The stopic criteria is when I arrive at the leaf, as we said there in our here, the stoppage criteria is when I arrive here at the leaf. When I arrive to leaves, this is the stoppage criteria. Uh, uh, the stoppage criteria, as you see, is when the input becomes empty. So here, if the length of the array, the input array, equals 0, in this case, I will just copy the bucket into the collector. Then the collector dot add append the node, a copy of the node, the whole node, and return how to go through that. We can simply do it like that. How to get children? Okay, let me the number of tiles equals here generate how to generate children. Simply, I will look through the elements of the array. For each elements, because I will depend on removing and getting back, removing and getting back. So it will become something like that. In our case, if this is 1, 2, 3, it could be this for loop is executed 3 times. First of all, I will take an element from array and append it to the bucket. So the bucket, which is the node, take from the input, take the first element in the input, and then recursively call here the recursion is here. How to recurse? By calling the whole thing, the whole or the same function, the input, the node, and the collector. Then after I finish, here is the backtracking here. Backtracking. How to backtrack is by taking the element which is appended to the end of the bucket, which is a node, and put it back in the array. But we take the first element, we put it back as the last element to be able to exploit the next element. So the input will append back what we added to the node to the back of the node. We take the back of the node, putting it into the like the node is like a stack. Also, the bucket is like a stack. We take and put in leaf order, while the input is like something called queue. So After we backtrack and we exploited the whole table, we will just retain here the collector, because the collector will contain the whole. Okay, let's test that. Yeah, the input is nums. Okay, let's run this whole thing. How to run it? Yeah, this is our code, and how to run it here in this. Mm, Defined. Oh, here is not array. Here the input. Yes, yeah, and that's correct. And thank you for listening. And thank you. I will end the meeting here. And stop recording here.